Hi everyone, I'm Hiromichi Kamata from Sony Group Corporation. Today I'll present B³-Seg, a camera-free, training-free, open vocabulary segmentation method for 3D Gaussian splatting scenes. 3D Gaussian splatting, or 3DGS, has become the go-to representation for real-time 3D scenes. But to make those scenes truly useful, we need to identify individual objects within them. That's the task of 3DGS segmentation, assigning each Gaussian to a semantic object, so you can interactively extract, edit, or query any part of the scene. For example, show me the teddy bear, purely from a text prompt. Why does this matter? In VFX and film production, artists capture real sets with 3DGS and need to isolate props and characters for compositing. In robotics, agents operating in 3DGS-mapped environments must localize target objects to grasp them. In AR and digital twin applications, components need to be segmented on the fly without any pre-labeling. All of these demand fast, interactive segmentation, without reconstruction cameras or manual labels. So what exactly is our problem setting? We start from just a pre-built 3DGS asset and a text prompt. No reconstruction cameras. No per-scene training. The system must return a segmented 3DGS object in a few seconds. This camera-free, training-free, open vocabulary requirement makes the problem fundamentally harder than prior work. Here's why it's hard. 3DGS is a view-dependent representation. You need to look at the scene from multiple angles to correctly identify which Gaussians belong to an object. All existing methods either require the original reconstruction cameras or per-scene training, or both. As shown in this table, B³-Seg is the only method that is camera-free, training-free, and requires no ground truth labels. Our pipeline has 4 steps. First, we initialize a Beta-1 prior over each Gaussian, representing uniform uncertainty about foreground membership. Second, we sample candidate viewpoints on a sphere around the object, without any camera pose information. Third, we score each candidate using an analytic expected information gain, computed from a single render. Finally, we select the best view, run grounded SAM2 and clip once, and update the beta posteriors. The key insight is, SAM2 only ever runs once per iteration. Let me explain the Bayesian formulation. Prior work like FlashSplat assigns Gaussian labels via a deterministic linear program, which requires all reconstruction views up front. Instead, we model each Gaussian's foreground probability as a beta-distributed random variable, and each view observation as a Bernoulli likelihood. Thanks to Beta-Bernoulli conjugacy, the posterior update is closed form. Each new view simply increments the 2 beta parameters. This gives us a principled uncertainty estimate over every Gaussian, which is exactly what we need to decide which view to look at next. Now, how do we efficiently select the next best view? The naive approach would run SAM2 on every candidate. With 50 candidates, that's 50 full inferences just to pick one view. Instead, we derive an analytic approximation of expected information gain using the current beta means. This requires only a single render per candidate, with no SAM2 at all. EIG measures how much each view reduces the entropy of our Gaussian posteriors. Views with less occlusion naturally score higher. This greedy view selection has provable guarantees. We show that EIG is adaptive monotone and adaptive submodular, which means greedy selection achieves at least 1-1 over E, about 63% of the optimal, providing the first theoretical bound for view selection in 3DGS segmentation. Looking at qualitative results on the LERF mask benchmark, B³-Seg produces consistently cleaner segmentation boundaries and more complete object masks compared to existing methods, especially for objects with complex geometry like stuffed animals and translucent materials. Quantitatively, B³-Seg achieves 84.5 MIOU on LERF mask and 95.1 on 3D OVS. Improvements of 14.9 and 4.9 points respectively compared to the camera-free FlashSplat baseline. The full pipeline runs in 12.1 seconds on an RTX A6000, making it practical for interactive workflows. To summarize, we presented B³-Seg, the first camera-free, training-free 3DGS segmentation method with provable guarantees. By combining Beta-Bernoulli Bayesian updates with Analytic EIG guided view selection, we achieve state-of-the-art performance in seconds. Thank you. Please visit the project page for more details.